Idaho Supreme Potato Company has installed an innovative type of coal conversion system. Shown here is the company's over-the-road truck which delivers the coal to the plant. The coal is discharged from the bottom dump trailer over a grizzly and into the receiving pit. 2-inch by 0 bituminous coal is used, containing 13,000 BTUs per pound and up to 8% H2O.
Show me some of the coal. Does it all go through?
Some of it, the oversize is kept on top of the grizzly, and the undersize falls through the grizzly, into the chute, and down into a screw conveyor.
Where's the screw?
Screw conveyor.
Oh, okay. The screw conveyor goes from there.
Draws the material up into the screw conveyor, and then drops it down past a magnet.
Where's the magnet? Show me the magnet.
Magnet's right here. Material passes over the magnet.
All right.
Drops into the bucket elevator.
All right.
Which brings the material up to the top of the bin.
Okay.
Storage bin holds about 400 tons.
400-ton capacity then represents slightly more than 4 days operating time, as we will be burning at a rate of 4 tons per hour in the boiler. After unloading, the coal truck begins its round trip back to the coal mine. Completely enclosed and neatly installed inside the lower portion of the 26-foot diameter Butler storage silo is a complete coal pulverization system, including feeder, Williams DF52 pulverizer, cyclone collector, main circulating fan, and pulverizing coal transport fan. The wind box of the DF52 pulverizer can be seen through this access door. We are now inside of the coal storage silo, and shown is the Karman vibrating discharge feeder, which is located at the bottom of the coal storage bin. This feeder prevents bridging and ensures continuous coal flow to the Ramsey Waybelt feeder. This is a close-up of the feeder inlet section.
It passes a gate. Coal passes down this conical section through the coal shutoff gate, which is in the open position. Enters the Waybelt feeder at this point. Enters the belt of the truck at this level. Travels at a very rapid speed, depending on demand. Discharge. Head going. Goes down. Chute below the floor and on. Discharge from the Ramsey volumetric weight feeder travels vertically down to the inlet of this screw conveyor, which transports the coal into the DF52 at this point.
This is a cross-section of the Williams DF pulverizer and its main skid-mounted drive assembly.
125 horsepower, 1800 RPM Toshiba motor. It is direct connected to a default right-angle gear reducer with a 15.12 to 1 reduction ratio. This mill motor is controlled by a variable frequency AC control. This is an extension of the automatic grease lubrication system, which puts grease into the main mill bottom bearing at this point.
The pulverizer cross-section shown here has a large access door through which journal assemblies are easily removed for yearly maintenance. Shown here are 6 DF52 pulverizers under construction at the Williams Bonne Terre plant in Missouri.
Okay, bring it around so that we can see the lubrication system. All right. All right, indicate how the grease goes down the hole.
Grease goes down to the hole
through that line.
Unlike bowl mills, the Williams DF mills have no springs. Crushing force is derived by centrifugal force. The journals are free to roll over uncrushables. For purposes of demonstration for this picture, the pulverizer access door has been opened and the pulverizer operated at a slow speed. Note, faster operation would be hazardous. Capacity adjustment is achieved by varying the central shaft rotational speed. Each Williams DF mill is equipped with a tramp metal throwout chute. By opening this large gate, removal of hard-to-grind materials is accomplished. This is done periodically, normally into a wheelbarrow.
Shiny nut.
Where's that? Hold that up.
There's that nut.
Oh, I see. Certainly nice and bright. Okay, anything else?
Here it is. There's a piece of metal in there. It looks like a
Ring it.
dog. And
Well,
here's
get it
some
on the ground.
slag.
Okay, so it accumulates at the bottom. Williams uses an active classifier we call a spinner separator, which is located directly above the DF pulverizer as shown here. Because of the dynamic classifier design, sieve analysis of the pulverized coal remains at 95% minus 250 mesh at high or low loads.
This is a steam coil type heat exchanger, which has the transport air passing through it. The hot gas then enters the inlet of the mill at approximately 200 to 250 degrees Fahrenheit. Hot air travels in this direction, past a thermometer reading from 0 to 550 degrees Fahrenheit. After the thermometer, we have a isolation damper. This isolation damper is actuated by a pneumatic cylinder. This is the main circulating air fan. The air that is separated from the coal in the primary cyclone is returned back to the inlet of this fan. It then travels down this pipe directly into the inlet of the DF-52 pulverizer. The Williams Dynamic Spinner Separator air classifier, located directly above the DF-52 pulverizer. The sized coal leaves the spinner separator, enters into the turret section, discharges into the ductwork heading to the inlet of the primary cyclone collector. The air and coal are then separated in this MAC high-efficiency cyclone collector.
The material comes down.
The material comes down and enters the rotary valve, which then enters the coal transport system. And at this point, the transport air is taken from the system and goes upward to the inlet of the transport air fan, which is on the second floor. This is where the transport air is delivered into the inlet of the constant volume transport fan. Discharge and makes this elbow. And at this point,
From the transport air fan discharge, the pulverized coal is conveyed out of the coal pulverizing area into the building that houses the boiler and coal burner.
The Cohen burner.
The coal travels past this coal shutoff valve and enters the Cohen burner, which is located on the front of the boiler. The burner is designed to fire coal, gas, or oil. The burner and burner management system were supplied by Cohen. This then is the Cohen dual air zone scroll feed multi-fuel burner. The flame pattern can be changed by adjusting the louver assemblies located at the core air zone and the annulus air zone. The overall view shown here is of the coal storage silo on the right, the boiler and boiler room in the center, and the baghouse and fly ash hopper to the left. This is the back end of the Bigelow Type A open bottom Model 4224A-82 boiler, modified by Holman Boiler Works. The furnace volume is 2,760 cubic feet and has a total heating surface of 7,300 square feet. The boiler is rated at 70,000 pounds of steam per hour at 140 psi when firing coal. The design heat input is approximately 95 million BTUs per hour. By looking in the observation viewport, we can observe the coal flame at various boiler demands. This flame is at 15% demand and has a 10% gas igniter.
Okay, can you ask him to take it up?
Now 25% demand.
We are now at 25% boiler demand.
This represents 1 ton an hour of coal.
Flame is burning entirely in the length of the cone.
The boiler has now been brought up to a 50% load.
This then represents 2 tons an hour of coal. In this view from the roof level, you can see the baghouse and exhaust fan for the boiler, which are in operation. Note how clean the exhaust gases are. This installation was required to meet the most stringent clean air requirements. The boiler is presently operating at 100% demand. Because this system was started up in their off-season, the entire 70,000 pounds per hour of steam had to be vented to atmosphere as there was no plant demand. This is the 100% coal flame at full boiler demand. The coal has been pulverized to 95% minus 250 mesh. When in normal operation, this steam will be used to process and dehydrate 1 million pounds of potatoes daily. The conversion from natural gas to coal is presently saving Idaho Supreme potatoes over $125,000 per month.